You hear me?
Yep.
Cool. Basically, I'm here to show you how we solve the problems we have, the challenge we have with PAKET on top of Stella. And for that we need to explain the problem a bit. I take it none of you have heard from Owen exactly what it is that let's call it smart contract does. So I'll explain it I'll say it in phases. Okay, the most basic thing that we do is promise payment. We have a guy who's picking up a package, and he wants to know that once he delivers the package, he's going to get paid. So this is a very classic kind of virtual escrow. The coins disappear from the wallet of the person who's launching the delivery, and they're held in this untouchable cloud. And of course, we need to have a way for him to retrieve this if things do not go according to plan. So let's say if the packet hasn't arrived at its destination within a couple of weeks or whatever the deadline is, there has to be a way to retrieve it back. And there has to be a way for the courier to be able to trust that once he delivers the package, once he gets the signature from the recipient, then these coins are going to show up in his pocket. That's pretty simple. Again, we did this originally in a pure Bitcoin implementation, using script, and I don't know how many of you know this, but it's cumbersome, but it's entirely doable. There are many known schemes for doing pretty much this. Having an escrow and having a deadline and being able to get it back and having a refund transaction. So that's like the first simple space. It gets slightly more complicated because we also have the collateral. The courier who's picking up your package needs to commit some collateral to make sure that it doesn't just take your package and run away. And often the collateral is much higher than the payment. It's a form of insurance, really. So the escrow also needs to hold this, and again, to let the launcher retrieve it once the deadline is over. So you're going to get your insurance back because the package isn't where it's supposed to be. And of course, it needs to return the collateral back to the courier who deposited it in case of a successful delivery, proven delivery. And then comes the complicated part, which is that the entire thing needs to be sort of recursive. So once I pick up a package and I'm committed and I'm going to pass it, I don't know, somewhere else, I need to be able to subcontract another courier. We call this a relay. I need to be able to relay the package to someone else, and that someone else is going to get a part of the payment, which we are going to agree upon. And not only is he going to get a part of the payment, he also needs to cover my collateral. So he can just give me the collateral back, but he needs to have a way now that when the payment arrives, he's going to be the one who gets the collateral. I'm going to move this. And this, of course, can happen many, many times.
Israel, maybe I'll stress this point, just to explain the mechanics of what's going on. What's your name? I'm sorry. Ivor. So I gave my thing to Ivor, so he will give it to Nemanja. I'm telling you, you'll get 10 tokens to do that, but don't lose it. So to make sure that you don't use it, I'm asking you to put 100 of your tokens in some collateral, right? So now I'm putting my 10 and he's putting his 100, and when Nemanja will sign it, he will get his 100 back and my 10 payment, right? If he will lose it, I'll get my 10 back and his collateral. That's the insurance. Now, if he transfer it to someone else, to Katerina, and tell her, look, you will get 5 of my collateral, then when Nemanja will sign it, he will get 5 and Katerina will get 5. Of the 10, right? However, he already gave me 100 to secure this thing. So he will not give it to Katerina unless she will put 100 inside, and now he's getting his 100 back. So what happened is the person who's holding this, who's holding my phone, always will get some of the payment, but the person who's holding this is always collateral, because his 100 will be paid to me if he loses it. Okay, so this is the scheme that we're creating it. So it's an endless, so Katerina can transfer it to someone else to take part of her 5, so that's the recursive part. So my payment goes to many, many people around the world, but the collateral is always with the person who's holding this. Okay, this is the basic scheme.
Okay.
Yeah, the important thing is that payment and collateral behave differently. Because payment keeps getting distributed and collateral just gets passed. And again, originally we did this with Bitcoin, and we managed to get all the cryptography done, and we even did some around the pretty work, make it available on the web, and I don't know if it was that pretty, but it was working. And then on the second iteration, like Owen said, we started with Solidity. And basically, I'm going to compare throughout this talk, to compare Stellar to Bitcoin and Solidity, because these are not only the two most popular blockchains, distributed, whatever, around, they're also the path that we went through. So we have good comparisons there. And of course, script, this is the language we use on Bitcoin, is cumbersome. It's like Forth, it has this stack, and you need to pick things up, and it becomes really, I don't know, it's not elegant. And of course also the fees are prohibitively high, and it's pretty slow, but we're good with that. And there aren't native tokens, but we can use something like colored points, and basically it works. When we moved to Solidity, the first thing was that, wow, it's so much easier. Because in Solidity the transactions are code, and you have your variables inside, and your storage. And you just write down things, and really, the basic implementation is almost trivial. I think the first challenge that we had was to optimize it, because once you use Solidity, there are so many ways to do things. You can do it so much cheaper, gas-wise. You can do it in like less operations, and then hopefully it's a bit more stable, and there are less crazy bugs out there. So the optimization is a bit harder and really fun. But like Oren said, Solidity is a bit of a horror show, in my opinion. It's amazing, but it has so many strange behaviors, and generally I think it's proof that the road to hell is not just paved with good intentions, it's paved with incredibly intelligent and competent people who have these intentions. And by that time, we already had the layer architecture in mind. So Owen didn't really get into it, but like, I don't know, like good engineers, we set up layers, like in communication protocols. And the most basic layer, we call this L0, is the one that enables the consensus, the distributed trust, whatever. And on top of that, we built L1, which is the packet, which is exactly what we described now, this basic solution. Then the L2 is about routing with this, and L3 is about actually using it, and then we have an organizational level, and so on. You can read all about it in our white paper. But anyway, at that point, we already knew that we need to be very flexible with L0. We need to be able to use whatever just comes up. So after a while of using it with Solidity and of building some things on top of it, we made the move, and we moved to Stellar. Now, Stellar, I understand that none of you has worked with it. How many of you have heard about Stellar, read about Stellar? How many of you know Stellar? Okay, not many. Oh, some more.
Quite a few people.
And Owen, yeah, I know you know Stellar. So basically, Stellar, just like Bitcoin, just like Ethereum, is a distributed ledger, which is an ordered collection of transactions. And the thing about it that it has coin interactions in mind, which is true of Bitcoin, but definitely not true of Ethereum. It is not permissionless, so it's not as trustless. This is a good point that Oren makes. That you hear the word trustless a lot, but when we say trustless, we really mean not without trust, but that trust doesn't matter. That it's trust agnostic. So maybe it's not as trust agnostic because it is made up of a federation of peers that do have a lot of it's very hard to cheat because there are many eyes, many people, many different interests. None of them, of the so-called miners, actually work for fee. The fee is distributed back as a form of inflation into the coin. And it's sort of, maybe it's a middle ground between the wonderful, idealistic, fully distributed, trustless, decentralized world of Bitcoin and the world that we have today. So in a way, it actually makes a lot of sense because it is clear that society is only getting ready to all this decentralization. And I hope that Stellar and the likes of Stellar can be stepping stones. But that's an important thing to notice, that it's not as purely decentralized and permissionless and I don't know if elegant is the right way, but ideologic as Ethereum and Bitcoin. Unlike Ethereum, the transactions are not free-form code in Solidity that you run. And unlike Bitcoin, like Bitcoin, it's operations, but unlike Bitcoin, the operations do not define a negative space of transactions. Now in Bitcoin, every transaction has inputs and outputs, and the value is actually what's in between. In Stellar, the operations that make up transactions there are 12 operations. You can see the list of operations in the documentation, and they're specifically designed for payment and value exchange. They even allow some, let's call it dark operations or highly centralized operations, like issuing a coin and having full control, having to whitelist basically anyone who works with it. So you can forbid people from using your coin. And this, to if you tell this to Bitcoin missionaries, they cry out. But basically, it's extremely practical, and I think that's a big part of the reason we use it. It just delivers. Stellar is used. It has the Stellar core. I guess this is the full node you would call, but the only interaction with it to the outside world is always through a Horizon server. Horizon is a web server. It's an API server that gives you all the communication with the base. So, and again, this may sound a bit strange, but it really makes things easy. And basically, even when we wrote it with Solidity, the first thing we did is set up a Swagger page, set up an API page, so you could use HTTPS and JSON to talk to it, and not, I don't know, Bitcoin it was RPC, right? So Stellar has this built in. And then specifically for our implementation, and this is something that we weren't absolutely sure about, but eventually we made a decision and we wrote a Python library. It's called PAKET Stellar, and this library sort of helps you use Horizon. So it's even a second layer. The reason we wrote it is to make development faster for third parties, but it actually has another very important value, and this is the fact that we can always change the underlying L0. Right? If you want to move back to Ethereum, you want to move to EOS, to whatever, we always have this API that is very packet oriented, that gives you the packet operations. And this sort of translates currently to Stellar, used to be Solidity, and who knows what it's going to be in the future. Okay, so the biggest problem with Stellar, pretty much anyone you ask about it, it doesn't have smart contracts per se. So basically, we needed to okay, Stellar says that they do have smart contracts, but they're not that smart. The point is that you usually don't need extremely smart contracts. Usually, you don't need not even the full stack of script that Bitcoin uses that allows you wonderful things. But I think 99% of the uses do not really need it. This can be actually viewed on the blockchain. Almost all of the transactions are the simplest kind of just moving Bitcoin from place to place. On Ethereum, you have very complex things, but again, many of them aren't really that practical. They're more gimmicky. And when what you have in mind is exchanging values, it turns out you don't need that many operations, you don't need that many options to solve a moderately simple problem like the one I described to you. So let's see what we do have and how we solve this problem. And I'm going to actually share the screen and show you some code. Does that work?
Yep.
Yeah.
You see code?
Yeah.
Yes.
Okay, so this is the library I was talking to you about.